Hello everyone. Let's look at Euclidean geometry grade 11 and grade 12. But before we even start with grade 11 and grade 12 theorems, let's tap into grade 8, grade 9 and grade 10 theorems. So we will start from lines. So in grade 8 and 9, you learned about lines. So number one, we have angles on a straight line. So if you have a straight line, here is the straight line ABC. So you need to remember that all angles on the straight line, they add up to 180. So that simple means this angle here, angle B1, plus this angle there, angle B2. If you add them, they must always give you 180 degrees. So angle B1 plus angle B2 is always equal to 180 degrees. So in Euclidean geometry, every statement must be accompanied by a reason. So here, you just say these are angles on a straight line. So that simple means in the test or exam, if you have a straight line and one angle is known, let's say for example, angle B2 is 100 degrees. So if angle B2 is 100 degrees, that simple means angle B1 will be 80 degrees, because if you add these two angles, they must always give you 180 angles on a straight line. And then number two, we have two straight lines that are crossing. So if two straight lines are crossing, we get what we call vertical opposite angles. So vertical opposite angles are always equal. So now in this diagram, angle E1 is the same as angle E3. So these are vertical opposite angles. So angle E1 is equal to angle E3. So when you write your reason, you just say vertical opposite angles. They are equal. That is how you write your reason. Vertical opposite angles are equal. We also have angles in a revolution. So angles in a revolution, or angles around the point, they will always give you 360 degrees. So if you add all the angles around the point, they will always give you 360 degrees. Even here, if you were to add all these angles, they will give you 360 degrees. So here, that means angle E1 plus angle E3, or let me start with E2 plus angle E2 plus angle E3, it is always equal to 360 degrees. And then when you write your reason here, you just say these are angles around the point. Or you can say angles in a revolution. So if you add all of them, they will always give you 360 degrees. Now, let's move to parallel lines. So under parallel lines, we look at that fun part of mathematics. So now, under parallel lines, number one, we have corresponding angles. Corresponding angles are always equal. So here we can see that line AB is parallel to line CD. So remember, in the test or exam, you need to be told that lines are parallel. If it is not written in a statement, they will denote with these arrows. So these two arrows, they tell you that lines are parallel. Now, so if two lines are parallel, you can get corresponding angles. So here, for example, this angle here correspond with this angle there. Correspond with that angle there. So that simple means A is equal to what? A is equal to B. So when you write your reason here, you just say these are angles. These are corresponding angles. But why are they corresponding? They are only corresponding because AB is parallel to CD. So you need to mention lines that are parallel. So you can't just say corresponding angles and leave it like that. So you need to mention lines that are parallel. So AB is parallel to CD. So under parallel lines, we also have alternating angles. We also have alternating angles. So again, we can see that these two lines are parallel. XY is parallel to WZ. So now, these two angles here, this one and that one are alternating. So alternating angles are also equal. So you will see something like Z or N. And then that is how you are going to spot the alternating angles. So A is equal to B even here. Why? These are alternating angles. But why are they alternating? Because line XY is parallel to WZ. So you can't just say alternating angles without mentioning lines that are parallel. We also have co-interior angles. So now, co-interior angles, these ones are not equal, but they add up to 180. So if you see, you can see that line RS is parallel to line TU. Now, you'll see something like U. So when you see something like U, here is our U. Okay. And then you know these two angles, when you add them, they will always give you 180. So that means angle A plus angle B, these ones are not equal, but they add up to 180. So if you add the two, you get 180. And then reason why are these two angles add up to 180? These are co-interior angles. Why are we having co-interior angles? Because S is parallel to TU. Okay, so again, under parallel lines, sometimes we'll in the exam they will just give you lines. Sometimes in the exam they will ask you to prove that lines are parallel. So if you want to show or you want to prove that lines are parallel, let's look at line AB, for example. Line AB and line CD. If you are required to prove that these two lines are parallel, that means you need to use other theorems to calculate angle alpha, also calculate angle beta. Let's say, for example, your angle alpha is equal to 50 degrees. And your angle beta, if you calculate it using other theorems, you find out that angle beta is also equal to 50 degrees. Since these two angles are now equal, angle alpha is 50, angle beta is also 50 degrees. So you can then conclude and say these two lines are parallel. So in the exam, you will say angle alpha is equal to angle beta. They are both equal to what? They are both equal to 50 degrees. Therefore, you can conclude and say line AB is parallel to line CD. Why? Because corresponding angles are equal. So since corresponding angles are equal, you can conclude and say, oh, line AB is parallel to line CD. Or let's look at line XY as well as WZ. So now if you are required to prove that these two lines are parallel, so you will calculate angle theta using other theorems. You will also calculate this angle alpha using other theorems. If you find out that these two angles are equal, if angle theta is equal to angle alpha, you can then conclude and say, therefore, XY is parallel to WZ. Why are you saying that? Because alternating angles are equal. So if these two alternating angles are equal, that means these lines are parallel. Or you can use co-interior as well. So now let's look at line RS and TU. So now if you look at these two lines, if you are required to prove that they are parallel, so if you calculate angle theta as well as angle beta, the sum of these two angles must give you 180. So if angle theta plus angle beta is equal to 180, so that means you will calculate this angle using other theorems. You'll also calculate this angle using other theorems, and if the sum of the two angles can give you 180, you can then conclude and say, therefore, line RS is parallel to line TU. Why? Because co-interior angles add up to 180 degrees. So that is how you prove parallel lines using grade 8 and 9 theorems, because in grade 10 there is also a midpoint theorem that can be used. In grade 12 there is also proportionality theorem that can be used. But for now, since we are discussing theorems that you learned from grade 8 up to grade 10, we are only limited to co-interior angles, alternating angles, as well as corresponding angles. So now let's move to triangles. We also have triangles that you need to remember. I'll try to move a little bit quicker so that we get into grade 11 and grade 12 theorems very quickly. So triangles, you need to remember types of triangles: equilateral triangle, scalene triangle, isosceles triangle. You need to know the properties of those triangles. So now, for any triangle, so if you add all the angles in a triangle, remember, they must always give you 180. So that means here, angle A plus angle B plus angle C is equal to 180 degrees. Remember, every statement must be accompanied by a reason. So the reason here is sum of angles in a triangle. So sum of angles in a triangle, they always give you 180. So for any triangle, if two angles are known, it is very easy to calculate the third one, because sum of angles in a triangle must give you 180. For example, if this angle here is 70, and then this one here, maybe it is maybe this one is 60, you already know that this one must be what? Must be 50, so that the sum will give you 180. And then number 2, under triangle, if line BC is now produced at D, so this line is now extended, you will then notice that there is an angle that is formed here outside. So this angle here, angle C2. So C2 is the exterior angle of a triangle. So this angle that is formed here outside, angle C2, is the exterior of a triangle. So angle C2 is always equal to the sum of opposite interior. So C2 is always equal to angle A plus angle B. So the reason here, you just say this is exterior angle of a triangle. So exterior angle of a triangle. C2 is equal to angle A plus angle B. So that means, for example, if your angle A is 40 and then your angle B maybe is 60, so that means your angle C2 will be 100. So this one here will give you 100, because if you add these two, the opposite interior, they will give you the exterior. So exterior angle of a triangle is equal to sum of opposite interior. And then we have this one, which is an isosceles triangle. So I like isosceles triangle because even if you have one angle, you can easily calculate another 2 angles that will be missing. So now with the isosceles triangle, so angle B, so this angle here is always equal to angle C. Can you see the lines that are equal? They are coming from vertex A. So you will just ignore angle A. And then that means these 2 angles here at the bottom, they are equal. So angle B for an isosceles triangle is always equal to angle C. So the reason here, we just say these are angles opposite equal sides. So the angles opposite equal sides are always equal. So now even if you have one angle in this triangle, you will be able to find other 2 missing angles. Now here is a small example. If this is an isosceles, if this angle here is 40 degrees, for example, you already know this one is also 40. So why? Because of angles opposite equal sides. And then the remaining one you can calculate using sum of angles in a triangle. If this one is known, let's say for example you have this one as 100, so you can again easily calculate these 2 here, because you can call this one x, even this one will be x. Now to calculate this value of x here, you can just say x is equal to, we just say 180 minus 100 divided by 2, and then you'll always find your x as x is equal to what? Is equal to 40, and then you'll write both reasons. So you'll start by saying sum of angles in a triangle, and then also you have angles opposite equal sides. And then now let's move to cyclic geometry, grade 11 and grade 12 theorems. All right, now let's look at cyclic geometry. So here we have 9 theorems that we are going to discuss, but these theorems can be grouped into 3. So group number 1 has to do with center, group number 2 has to do with cyclic quads, And then group number 3 has to do with tangents. So let me start with group 1. So now, for argument's sake, throughout the discussion, O is the center. So O is the center because in the exam, you need to be told that you have a center. You do not assume that a point is a center without being told. Now, the first theorem here says, if you have a line from center, okay, as we can see our line from center, okay, let me put 90 degrees here first. Okay, if you have line from center and that line is perpendicular to the chord, so if it's perpendicular, that means it makes an angle that is equal to 90 degrees. That line will bisect the chord. So remember, bisect means divide into 2 equal halves. So now the minute you see this line that is coming from the center and the line is making an angle that is equal to 90 degrees with the chord, you already know that AB is equal to BC. So in the exam, you will just see a diagram like this, and then you see this 90, and then your conclusion will be, oh, since there is this 90, you can then conclude and say, oh, that means AB is equal to what? Is equal to BC. Okay, so AB is equal to BC. Why? Because we have line from center perpendicular to the chord. So your reason here will be line from center perpendicular to the chord. So the line from center perpendicular to the chord will always bisect the chord. So that means if AB is 10 centimeters, BC is also 10 centimeters. But you must see this 90 first, and you must see the line coming from the center and making an angle that is equal to 90 degrees with the chord. That is your first theorem. So the reverse of this theorem is always true. Again, in the exam, if you are already told that line AC is already bisected, because you can see here that AB is already equal to BC. It is given from the diagram. So as long as the line is coming from the center, so that means B here is what? Is your midpoint, because AB is equal to BC. If the line is coming from the center and is passing through the midpoint of the chord, it is also perpendicular to the chord. So from this diagram here, you can conclude and say, oh, since this line is coming from the center, and it is through the midpoint, B is the midpoint, right? You can conclude and say, therefore, angle M, not M, but this is B, angle B1 is equal to angle B2. They are equal to what? They are equal to 90 degrees. Because if the line is from center and is going through the midpoint, it will make an angle that is equal to 90 degrees. So the reason here, you just say line from center of the circle, line from center to, and then you just say midpoint of the chord. Line from center of the circle to the midpoint of the chord. That is why you are saying B1 is equal to 90 degrees. Even B2 is also equal to 90 degrees. Okay, let's move to the next one. So under center, theorem number 2 says, if an arc subtend an angle in the center of the circle, you can see here we have, this is our arc AB. So if AB subtend this angle at the center of the circle, okay, here is the angle at the center, and then again the very same AB subtend another angle, but now not at the center of the circle, anywhere in the circumference. So here is angle C. It is also subtended by the arc AB. So the angle that is at the center will always double the one that is at the circumference. So that means here, if the angle at the center is 2x, the one that is at the circumference is what? Will be x. The one that is at the center is bigger than the one that is at the circumference, or is bigger than the one that is subtended on the circumference. So angle at center is always equal to 2 times angle at the circumference. Now, remember, the theorem is not saying the angle will always be subtended above. Can you see point C is above point O? It can be subtended anywhere on the circumference. So even here, if this angle here is the one that is at the center is 2x, this one will be x. Even here, we have the center, we have 2x, this one will be x. Even here, if this one is 2x, this one will be x. That is angle at center is equal to 2 times angle at the circumference. Now, if the angle at the center is 100, if the angle at the center is 100 degrees, the one that is at the circumference will be 50 degrees. So now, okay, so let me put it down here. If this is the center O, and then if this one is 100, this one is what? This one is 50 degrees. Reason is just write angle at center is equal to 2 times angle at circumference. So that is how you write reason. Angle at center is equal to 2 times angle at circumference. And then last one here is when we are given a diameter. So you will notice that your diameter will always divide your circle into 2 half circles. Your diameter will always divide your circle into 2 semicircles. So now diameter will always subtend 90 degrees. Diameter will always subtend 90 degrees. So this angle here, as long as it is subtended by diameter, you can see a diameter here. So it is subtending angle C, and then this angle here is always equal to 90 degrees. So we say the minute there is a diameter, you know the angle subtended by that diameter is 90. We say angle C is equal to 90 degrees. And then why are we saying that? Because it is subtended by diameter. You can say diameter subtend right angle, or we usually say angle in a semicircle. This is the most popular one, angle in a semicircle. But even if you write diameter subtend a right angle, that is also correct. So with this one, remember the reverse is always true. So in the exam, sometimes they will just give you a chord. So in the exam, they will just give you a chord. Let's say this is a chord AB. Okay. And then this chord subtend angle C, for example. Now, maybe they will give you this angle here and say this one, maybe this one is 30 degrees. And then this one, let's say it is 60 degrees for argument's sake. Now, they will ask you in the exam, is AB a diameter or not? So if they ask you that question, whether AB is a diameter or not, remember the diameter must subtend an angle that is equal to 90 degrees. Now, you will calculate angle C. So now, you can see here that we have a triangle. This is a triangle, right? So, and the angles in a triangle must add up to 180. So that means your angle C, to calculate angle C, you'll just say angle C is equal to 180 degrees minus 30 degrees minus 60 degrees. Why? This is sum of angles in a triangle. Now, therefore, what is angle C? Angle C will be what? Will be 90 degrees. Oh, this line here, AB, subtended an angle that is equal to 90 degrees. Therefore, we can conclude and say AB is a diameter. Why? Reason you will say chord subtend right angle, or you can say chord subtend 90 degrees. We are done with the first group that has to do with center. Let's move to the second group that has to do with cyclic quads. So under cyclic quads, we have 3 theorems again. So we have 3 theorems. We also have corollaries that I'm going to take you through. Now, the first theorem says opposite angles of a cyclic quad are supplementary. So that means as long as you see any four-sided figure with its vertices, you need to make sure that the vertices, they are on the circle. The vertices of a four-sided figure must lie on a circle. And then you can conclude and say the opposite will add up to 180. So that means here, you can see that A is opposite to angle C, and then angle B is opposite to angle D. So that means angle A plus angle C is always equal to 180 degrees. Even angle B plus angle D is always equal to 180 degrees. Reason here, you just say opposite angles. These are opposite angles of a cyclic quad. That is how you write reason. Opposite angles of a cyclic quad. That is number 1. Number 2, if now line CD is produced at E, so that means a line CD is now extended. Now, you will notice that there is an angle that is formed outside here. We call this angle exterior. So the exterior of a cyclic quad is always equal to opposite interior angle. So now that means angle B in this case will be equal to angle ADE. Remember, you can call this angle angle ADE. This angle, this exterior, is angle ADE. So angle B is equal to angle ADE. So ADE. Reason, you just say exterior angle of a cyclic quad. Exterior angle of a cyclic quad. So if this angle here is equal to 100 degrees, this one will be 100 degrees as well. So that is exterior angle of a cyclic quad. You will then notice also that here, because this is a straight line, remember, angles on a straight line, they always add up to 180. So if this one is 100, obviously this one will be what? This one will be 80. And you can see the first theorem here, we said this plus that must always give you again what? 180, because these are opposite angles of a cyclic quad. But the exterior one is always equal to opposite interior. And then third one, under cyclic quads, they call this a butterfly or a bow tie. So angles in the same segment are equal. So if an arc, so here is arc AB, subtend angles on a subtend an angle on a circle. Can you see AB is subtending angle C? If this very same arc subtend another angle on the same side of the circle, it is also subtending angle D. Angle C and angle D are always equal. So if this one is X, this one will be also X. Even angle A and angle B are also equal. If this is Y, this one will be also Y. So here you just say angle D is always equal to angle C. Reason here, we just say we call these angles in the same segment. That is how you write a reason. Angles in the same segment. Even angle A is equal to angle B. Same reason, angles in the same segment. We also have these corollaries that you need to remember. So the first one says if AB, here is AB, if AB is equal to DE, if these two chords are equal, they will always subtend equal angles. So that simple means angle F here will be equal to angle C. So equal chords subtend equal angles. So here we can say angle F is equal to angle C, and then you just say equal chords and then equal angles. So equal chords, they always subtend equal angles. Also, if here we have A, B, C, D. So if AB is equal to DC, these chords, if they subtend an angle at the center of the circle, so those two angles will be equal. So that means here, this angle is equal to that angle. So also angle AOB, angle AOB is equal to angle DOC, DOC. Again, equal chords subtend equal angles. So equal chords, equal angles. Move to the last group, which has to do with tangent. So here the keyword is the word tangent, or they will tell you that the line touch the circle at only one point. For example, they will say AB touch the circle at A, so that means AB is a tangent. Now the first theorem that I will discuss here under tangents is tangent is always perpendicular to radius at the point of contact. So here is your radius. It can be a radius or it can be a diameter. Even if it is a diameter, it is still fine. So, but at the point of contact, if AB is a tangent, they need to tell you in the exam, if this is a tangent, and then OA is our radius. So that means angle A2, even angle A1, it will be equal to 90 degrees. So this angle here, angle A2, also angle A1, they are equal to 90 degrees. Reason, you just say tangent is perpendicular to radius. Tangent is perpendicular to radius. It's tan red. So theorem number 2, this one is very popular. I don't think you will write any exam where tan chord theorem is not tested. So this one is tan chord theorem. So this theorem says if you have a tangent, so here is our tangent, AB or EB is our tangent. An angle between the tangent and the chord drawn from the point of contact. So this chord must be drawn from the point of contact. So here is the chord. Chord is AC. So here is the angle that is formed between the tangent and the chord. So that angle is equal to the angle subtended by that chord on the alternate segment. So that means this angle here, we can say it is A1, or we can call it angle CAB. So it is equal to that angle there. So you see the chord, here is our chord, subtends angle D. So if this angle here is X, even that angle there will be X. And then this is a tan chord theorem. Even in the exam, that is how you write your reason. Tan chord theorem. The angle between the tangent and the chord drawn from the point of contact, the chord must be drawn from the point of contact, is equal to the angle subtended by that chord on the alternate segment. Now, in the exam, sometimes they will ask you to prove that a line is a tangent. So now if they say to you, prove that a line is a tangent, let's say, for example, you are required to prove that line BD is a tangent to a circle ABC. So now to prove that BD is a tangent to a circle ABC, so you need to calculate, here is your chord. You need to calculate this angle here. So I can call it angle ABD. So let's say for argument's sake, your angle ABD is 3x. If you also calculate angle C, so if angle C is also equal to 3x, you will then say angle ABD is equal to angle C. They are both equal to what? They are both equal to x. Not x, but 3x. So here you have 3x. Even here you have what? You have 3x. So you can conclude and say this line is a tangent. That means there is a circle, even though the circle is not shown, that is outside here. There is a circle. And then why are you saying BT is a tangent? Or BT, let me put it down first. BT is a tangent. Why? And then you just say converse tan chord theorem. And then the last theorem that I will discuss with you, this one has to do with tangents. So for you to apply this theorem, the keyword will be tangents. So not tangent, tangents. So there must be more than one. So this theorem says two tangents drawn from the same point. You can see tangent AP is coming from point P. Even tangent BP is coming from point P. So if these two tangents are coming from the same point, the point must be outside the circle. They are equal in length. So that means the minute they tell you that this is a tangent and this is also a tangent. So since they are coming from the same point, which is point P, you already know that they are equal in length. So from this diagram, you can conclude and say AP is equal to BP. So when you write your reason here, you just say these are tangents. These are tangents from same PT. So tangents from the same point, they are always equal in length. So now from here, we are done with these theorems. So in the next video, I'm going to take you through past papers where we apply all these theorems. So, but before you even watch part 2 of this Euclidean geometry, make sure that you have watched and understand this part 1. So in the next video, I am going through past papers all the way to